Welcome, everyone. Thank you for joining the Transcend workshop. This is the first workshop of our first Virtual World Summit, so thank you for participating. My name is Amy Kim. I'm the Chief Operating Officer here at Technovation. Today, we are joined by Hannah, Min, and David from Transcend. Most of you have been part of our Technovation program, either through our family or our girls program. Some of you guys may be parents or mentors. But collectively, you guys have all participating in building a technology prototype that will help solve a problem in your community. Some of you guys have worked on AI products. Some of you guys have worked on apps. And hopefully, while you're working on your prototypes and inventions, you thought about what data you're collecting, what data is needed for your product to work. So today, we're going to learn a little bit about what types of data are important to keep safe, and what are some tools and algorithms that you can use to keep that information safe. Our hope is that you learn how to use these protection tools, how it works, and consider using them into whatever you build in the future. Just remember, I think you guys are already very active on the chat. If there's any comments or questions, please add them to the chat box throughout the workshop. We're going to be collecting them to do a Q&A at the end of the session. So now, without further ado, I am going to hand it off to the Transcend team.
All right, thank you all for coming today. It's really exciting to be here. We are going to spend a little time today talking about how to build a better user experience with data privacy. So let's kick things off by talking about stealing money. Jokes. I can tell that there's probably some concerned folks in the audience. So let's actually talk about preventing folks from stealing money. When you build product applications, and from everything that we've heard about what you're working on, it's pretty clear that you will, it's important to consider how they could be misused and to take precautions to prevent that abuse. So today we're going to walk through some fundamental tools to consider when you're thinking about securing your application. Before we do that,
why should you listen to us? Well, we all work at Transcend, a company whose core mission is to give product users control over their own data. So data privacy is super, super important to us. We handle data with the same degree of care that you might find at really large financial institutions. We all came to Transcend with a good deal of experience. I'll start with myself. My name is Min. I was, many of you can probably tell from my name, I'm Vietnamese American. I was actually born in Vietnam and moved to the US with my family when I was 11. I went to Yale University for college. There I studied philosophy, but then decided in my final year that actually I'd like to build things and not just think about things. So that's how I ended up in tech. At Transcend, I mostly focus on the testing and security of our core cryptographic application. Before that, I was at a company called Zendesk doing management and tech lead. My team there actually also worked on an application that dealt with handling user privacy requests. But you know, there I basically transitioned from a position where I was working on solving user privacy concerns for at a level of a single company to where I can solve it for all companies and all users, and at Transcend, and that's pretty cool. And I'll pass it on to Hannah.
Thank you, Min. I'm Hannah. I grew up in California, and I chronically did not know what I wanted to do with my career in high school, other than that I knew I wanted to have one. So I went to college. I majored in mechanical engineering, primarily through process of elimination. I was good at math, and it was easier to start in engineering and switch out of it than to switch into it. And I proceeded to do that for most of my career, process of eliminating my way into different paths, which, you know, isn't the most direct route to becoming an engineering manager, but it works. You can make it to any path that you'd like, regardless of how you get there, and you'll probably learn some fun things along the way.
Hello, everyone. So my name is David Matea. I'm also an employee at Transcend. I got really lucky. I discovered my passion for coding when I was in middle school, when my brother showed me on a TI-84 calculator how to program the quadratic formula to do my homework for me. I absolutely fell in love. I spent hundreds of hours with that calculator. I even gold-plated it during high school. I attended the University of Notre Dame, and where I graduated with a degree in computer science. During that time, I had a ton of really great and fun experiences. I worked in General Electric's aviation For an internship, I also interned at Amazon Robotics, where I got to work on self-driving robots that work in Amazon's warehouses to make Prime possible. I also worked for 2 years while I was in college at the South Bend Code School, where I got experience in EdTech, the bridge between education and technology. And I got to teach hundreds of students and absolutely fell in love with education and making it more accessible for those interested in technology. After graduating, I spent 2 years at Google working in ads, where I was working on machine learning models, specifically a type called quality-based disabling, where the goal was to remove clickbait and ads that weren't relevant or wouldn't be good quality to users. My wife and I, who got married around 2 years ago, decided to pack up and leave and go back home. We're both from Minnesota. So we made that move, and now I am a remote employee at Transcend with Min and Hannah and other great employees. I've worked here for a little over a year, and that move was also notable because I started coaching what we in America call soccer. I was just promoted from an assistant coach to a head coach, which is super exciting. I also included a picture of my dog, who my wife and I train and absolutely love. Her name is Mira. But let's get back to our content. We have a lot to cover today. The two major categories we're going to cover for the rest of the time are what is data and why is it important, and then how do you secure that data. So really boring slide at the beginning, but we got to define data privacy so that we make sure we're on the same page. What are we talking about here? So privacy, as I think we all know, the state or condition of being free from being observed or disturbed by other people. Data is a little bit harder to define. In this context specifically, we're talking about personal information, or PII, and these are pieces of information that if someone had them, could be tied back to you. This is things like your mother's maiden name, your birth date, your social security number, your credit card number, and your address. This information is incredibly valuable. Companies like Google and Facebook are extremely successful because of the data they collect on you and their ability to monetize that through targeted advertisements. Nearly 70% of all revenue in ads goes to Google, Facebook, and Amazon. And beyond that, if you look at individual companies' revenues, a company like Google will make over 80, sometimes 90, depending on the stats you use, % of its total revenue just from ads. And this is a company that has Maps and Gmail and is in all parts of your life. The primary way they make money is through these advertisements. And the more PII information they have on users, the better they're able to provide those targeted advertisements. So that brings up a good question of what do they actually know about you? And now, while not everything they know about you is used in their targeted advertisements, they do expose a lot of what they know, and it's good to understand what these companies collect by visiting one of these first two links. So they're for Facebook and Google respectively. These are links that I encourage you to use after this talk is done. But they show you your controls. So a lot of companies do give you controls over things like what data do you want to share with them? Do you want to share your location information? Do you not? Do you want targeted advertisements? Do you want random advertisements? You have a lot of those controls, and you should absolutely use them, or at least understand what your preferences are. Even if you don't change them, it's good to just know, what am I currently sharing with these companies? This third link, maps.google.com/timeline, is a tool created by Google built into Google Maps, where it actually shows you an interactive history of some of the data they've collected on you. I like using this as an example because I think some people may be surprised by the amount of information that Google has collected. Now, I'm going to show a couple examples from my Maps timeline to show how this data isn't just a collection of raw, independent data points, but it's actually a story. By connecting these millions of data points together, Google can formulate stories and learn a lot about you, more than just, oh, this is like X latitude and longitude at this time, which means very little. They can create stories and really understand your life. So here is a day, June 26, 2019, which was my very last day of working at Google. Now you can see I lived in San Jose at the time, and on the left-hand side, you can see the icons. It knows that I took a bus in the morning to work. It knows the route I took back. It knows I went and visited my wife in Palo Alto after work was done to celebrate. The next day, I immediately started working at Transcend. You can see my much longer commute up to San Francisco. You can see that little blue, light blue line at the top where I walked from the train station to work, and it knows that I took the Caltrain. And on the way back, again, went to Palo Alto. The next day, very similar, but it shows my team's offsite to the Golden Gate Park, where we went to the California Academy of Sciences together, and it shows how we got there. And then the very next day, it shows my flight to move back to Minneapolis. Now, I have no recollection of ever stopping at the Phoenix Sky International Airport on a layover, but Google remembers, because while my memory is fading, Google does not forget. This data is very easy for them to keep track of over time. So even though I've forgotten this story, they remember for me. And the last slide, I'll show the very next day, my first day moving into the new house. I didn't do a lot of traveling other than going to pick up food. But you can see it's even overlaid some pictures in the bottom left-hand corner. If you were to expand those, you would see water leaking into my basement, causing water damage on my first day in the new home, which was a very not fun experience. But it really goes to show that this data can tell a story. Even if I wasn't narrating these slides, if you had this data on me and you had this visualization, you could tell a fair amount about what I did on those days. And sometimes this data becomes public record. Typically, these companies try to hold on to this data because it's very valuable to them. But when there are data leaks or breaches or hacks, sometimes that information doesn't just stay private, and that's not a good thing. I'm going to pass it over to Min to talk about those cases.
If I can just let you guys know, there's a lot of chatter in the chat box about like this being very helpful, because like thinking about data safety, we have one of our finalist team who built an app to keep personal information safe, joined us in the workshop, so she's in the chat box. So some of the questions is, are there any perfect safety systems to keep all your data safe? And I think I see Hannah shaking her head. And then also another question was, can people access what data Google is collecting on them?
Great. I'll chime in on that second question. There's a link I didn't include, but the link is myactivity, all is one word, .google.com. And that will actually show you all data that Google has collected on you, and it gives you control to delete the data. I do think we'll cover that first question later in the slides. Min has a really nice section on.
Yeah, not David's Google timeline was pretty cool, but not all data collected are guarded safely. Like David mentioned, sometimes they are stolen or accidentally exposed, and these are called data breaches. They can be expensive, embarrassing, and sometimes dangerous. So some examples we'll go over today. In 2012, Target started sending catalogs and coupons for baby cribs and diapers to a teenager in Minneapolis. The unexpected coupons prompted a conversation within the family, and that's how her parents found out that she was pregnant. What happened was that the company had built a pregnancy prediction model to figure out when a person became pregnant so that they can send pregnancy-related advertisements to them. They was able to do this because they collected data on consumer spending habits and fed the data to this model. And that's how they knew, even before this family knew, even before the teenager had a chance to initiate that conversation herself. In 2015, every registered US voter had their data publicly available on the internet, their voting records, their political affiliation, their phone number, addresses, and names. This was in the public database with no authorization or encryption for quite some time. And at that point, anyone in the world could have discovered where a person in the US live and what political beliefs they have. This could be really bad, right? Like if you had a stalker or someone who wishes you harm, it's suddenly super easy for that person to know where you live and have all your private information. Another example, also in 2015, was a data breach involving a company called VTech, which made tablets for kids. They did not encrypt any of the data in their database. They didn't use SSL. They had many, many security flaws, and it was very easy for hackers to access the data that they stored on the children and their parents. So they had pictures and private chats of the children. They also have the parents' information, including the password associated with the account, which was very likely also used for other accounts that the parents had. And now those accounts are also no longer safe. Even when there is no data breach, data collection can be a violation of your personal privacy. In 2019, the New York Times released an article explaining just how easy it is to collect your data, your location data, if you had a smartphone. They got a bunch of location data from a random data company. This wasn't a telecom or a giant tech company. It wasn't a government surveillance operation, just a normal data company. One of dozens quietly collecting very precise movements using software slipped onto your mobile phone apps. In the visuals on this slide, you can see that in the first picture, like they're able to track more than 10,000 smartphones in Central Park. Then they're able to pick out just one of those smartphones and track the movements of that owner of the phone, and it's pretty precise. To anyone who has access to this data, your life is pretty much an open book. If you knew where a person worked and where they live, that's enough to pinpoint that person. You can know about what locations they frequent, they visit frequently. And with this information, the New York Times is able to track President Trump's precise location. And like it's not like the data is tagged with anyone's name or anything, but you can still make very educated guesses and figure it out. But yeah, maybe it's not the most secure thing that our president's location is just available at all times. So data is everywhere, data is everything. Most interactive customer experiences rely on personal data. If you want to track your user location to connect users to nearby services, you might accidentally offer hackers detailed location on your user. If you want to collect payments from your consumer, you might accidentally be handing over your consumer's credit card information. If you want to store user app behavior and usage metrics, you might be hurting your customer trust if they don't know how you're using that data. And that, in case of hurting customer trust, Target actually had to go back and tweak their targeted advertisement so that it seemed less targeted and more random. So, you know, for pregnant women, they would add completely random ads for lawnmowers or computers next to baby diapers and food so that it seemed less specific, so that people didn't feel like they were being spied on, even though they were, if they knew what was going on. So as a tech entrepreneur, you have to realize that it is your responsibility to handle your customers' data safely. And with that, I'll hand it over to Hannah.
So that's a pretty bleak picture of where we're at with data privacy today. The good news is that legal coverage for data rights is increasing, especially for folks whose internet regulation is influenced by the European Union. At the bottom of this slide are pictures of some of the legislation that's come into place recently that helps to enforce consumers' rights to protect their own information. One thing that I want to call out here is that even when there isn't legal coverage of data privacy, consumers are starting to become more educated on the topic. So in the US, 75% of people believe that the right to control who can access their information is very important. So that's just something to keep in mind as you're building applications. There's an asterisk on this slide because there are a few different internets. Technically, they're all connected. In reality, different places around the world do have different experiences of the internet. So in our presentation, we're predominantly focused on the EU-influenced model. Within the US, any multinational company that wants to have consumers outside of the US does need to be able to follow that EU model, otherwise they can't do business across Europe. But let's jump into these. So the US model is less regulated than the EU model. It upholds the openness and transparency expected by the internet's creators. That's both good and bad. The lack of regulation also means a lack of protection. So both free speech and hate speech can be spread really quickly. There's no protections for individual consumers, and mob rule can be a painful thing for folks, especially if they wind up being on the receiving end of it. The EU model is similar to the US model, but it does have more regulation. So it's targeted at minimizing bad behavior and increasing privacy protections. So stuff like consumers have the right to be forgotten. They have the right to request to have their information deleted. Then there's the China model, which is a bit more authoritarian. It uses surveillance and identification technologies to ensure social cohesion and security. And within, these are sort of the big three archetypes. There are some distinctions to be made inside of these. In India, access to the hardware that actually provides internet access is a bit more controlled. Sort of depends where you are. For this presentation, we are focusing on kind of that US-EU model area.
I have a quick question. I'm seeing a question from the chat. One of the questions was, why do countries have different regulations, especially around internet? If you guys have some thoughts on that. And also somebody asked, are we really prepared for a huge data breach as citizens of the world? And people were talking about the emotional toll of data breach is also very large, not just the fact that people can have access to your financial information.
Sure. So that was a couple questions. I'll see if I can answer them. I don't think I can do justice to all of them. But the first one was just why are there different types of internet? Sort of the same reason there are different laws in different countries. The internet is one of the first like globally shared resources. If you look at like regulation of the oceans or any shared commons, there's not necessarily agreement on how we should all behave. Some blocks of nations have agreed to behave in the same manner. Regulation is defined then largely as based on the beliefs of those blocks of groups. What was the next one? Are we prepared for a large data breach?
Yeah.
No. Like, with any risk, there are degrees of how bad it could be. And there are, 7 billion people on the planet right now. So your data could be out there, and if no one's looking at it, it doesn't matter. The issue with having your data out there is that if someone wants to find something about you, then it becomes much easier for them to do so. So as with all things, if there's someone being a jerk, then you're going to have problems. Having this data available just makes it that much easier for someone who has decided to be a jerk to behave poorly, to put people in danger, stuff like that. And if there was a massive data breach, I assume there'd be like some pretty bad fallout. If you look even at the stock price of companies who've had big breaches revealed, it really hurts trust. Their prices crash. At a certain point in time, there would probably be a degree of chaos, but those are all worst case scenarios. It's unlikely that everyone's information at all time would be released. There's definitely at least one Black Mirror episode about everyone's private information being released and worst case scenario, but proceed with caution. I can't watch those. They're too creepy for me. Did I answer all the questions? So,
yeah.
All right. Cool. So hopping back to the money, the data, let's start with a simple base case. So if a customer wants to be able to buy a product from your application, what kind of information do they need to provide in order to buy that product? And I'm going to wait while y'all throw some answers into the chat.
I'm seeing name, payment details, address, how old are you, credit card information.
Yeah, these are some great answers.
Yeah.
Sounds like y'all are pretty dialed in to what kind of things you would need to collect. It's quite a bit. So as you're collecting that information, how could someone hack that and get it? What avenues of attack would they have?
Someone wrote, some companies sell data through hacking, hack into websites of companies. Our activities throughout the day, spying.
That's another great one. So there are quite a few different ways, and I think that y'all have actually touched on all of them in some capacity. Someone could grab your information by being on the same network. So like if you're using a Starbucks public Wi-Fi, then someone could just grab your information in transmission. The unencrypted information stored on your system, also true. A disgruntled employee could cause a leak. There's a host of possible ways here that stuff could happen. Let's not allow that to happen. So there are several ways to secure data, and cryptography is one of them. OWASP, which I've included here, is the Open Web Application Security Project. They have a great set of resources on security design principles. If you ever want to refer to something, I'd recommend starting there. in answer to that question that someone had said earlier about, is there any silver bullet to solve security issues? The answer is no, but we can all certainly be smarter about how to protect data, and we can make it harder for folks to get that information. So cryptography is the practice and study of techniques for secure communication in the presence of third parties, called adversaries. More generally, it's about constructing and analyzing protocols that prevent third parties or the public from reading their private messages. So I think it's time to pass to David.
Yeah, if you guys can see my screen, let's talk about an example of a world without cryptography. And then, as Hannah said, we're going to dive into how we could use cryptography to eliminate some of those problems. So a very basic example, say you're in class and you want to share a note with a friend. You're pretty bored, so you say, I'd rather be coding right now. Now, as long as nobody sees you pass this note and you hand it directly to your friend and they read it and they're the only ones who read it, then mission is accomplished, because the only intended recipient of your message was able to understand what you wanted to convey without anybody else being able to read that message. Now, if anybody has tried to pass notes, you know that the main vulnerability in this attack is something like a teacher seeing you trying to pass that note. Now, what's not fun is the teacher going and reading that note. What's even less fun is they could even read that note to the class if they wanted to. And that might make you very sad. So the answer here, as Hannah mentioned, is to use encryption. When we say encryption, we're just talking about codifying your message so that even if your teacher was able to get the note, they wouldn't be able to understand what you were trying to say. A really fun example that we're going to use is a super old way of encoding a message called a Caesar cipher, which was first used and made popular by Julius Caesar in around 88 BC. Now, I have a little mapping here that shows A with an arrow to B, B going to C, C going to D. And the idea here is that in your message, each letter can be swapped out and converted into a different letter. So with a key of 1, you simply shift down the alphabet by 1 letter. So Z would become A, E would become F, and so on. If the key becomes 2, you would shift down by 2 letters. So A becomes C, B becomes D. If we look at an example with a very simplified alphabet, we're only going to say there are 6 letters, A, B, C, D, E, and F, and we have a key of 2. On the left-hand side of this screen, you can see a mapping of what each letter would become, and you simply go letter by letter, converting down. So A would become C, B would become D, the next A would become a C again, and you would end up converting a bad cafe into the message Kadikafa Ekaba, which makes no sense unless somebody knows specifically how to decrypt that message, which is the process of going back to a bad cafe. Well, how do you do that? If you receive the message, you're the friend, and you see Kadikaf Ekaba, and you know already that the key was 2, you just flip the arrows of your message. So now C becomes A, D becomes B, and so on until you can go from Kadikaf Ekaba back to a bad cafe. And you can read that message, but if somebody had intercepted Kadikaf Ekaba, they would not have known what you were talking about. But this is an imperfect method. It was used for around 800 years in the real world, which is incredibly impressive. But in the modern computer era, it doesn't work anymore. So just some of the problems are, one is to do this method, you have to be able to securely share a key with your friend. If they don't know that they're supposed to turn back by 2 letters, they won't know how to decrypt your message. And how do you share that key securely with your friend? Well, it's a cyclical problem. You could try using a cipher to share that key, but you'd need a key for that cipher, and so on. And there's really no way to do it unless you have at least one trusted message that you can share with that person. The second problem is that attackers only need to try 26 keys in the English alphabet at least. A can only become the other 25 letters. Or it could become itself with a key of 0. So it would be pretty easy if you intercepted one of these messages to just brute force, as we call it, which is to try all of the keys until you see a message that makes sense. The third problem is that in languages, letters aren't equal. As an example, in most languages, and English this is true, E is the most common letter. So if you're reading an encrypted message with a Caesar cipher and you see that F is the most common letter, you can reasonably guess that the key would be 1 because E's would be converted to F's. With that, I'm going to pass it over to Hannah to talk about some more modern approaches that are used in modern day computing.
And yeah, so building on what David said, if we flash forward from 44 BCE up to today, with the massive amounts of compute available to us, we need encryption that's a little bit trickier to hack. One smartphone today has about 100,000 times the processing power of the Apollo 11 spacecraft, which is the one that took man to the moon. So it's compute power is much cheaper today and much more readily available than it ever was in the past. One thing that I want us to touch on is just how many messages we're sending today as well. Like, when was the last time you sent a text message to someone, or an email, or a Snapchat, an Instagram story? I'm gonna keep running. We got TikTok. How many websites have you visited this week? How many apps have you used today? Every time you're connecting with one of those applications or with someone else, you're exchanging a message with them. So we are doing that with alarming frequency. Well, alarming is maybe the wrong word. We're just doing it a lot. And almost every time we do that, we're doing a Diffie-Hellman key exchange. So that issue that David had talked about how will your friend know that the cipher shift key is 3 or 2 or whatever, Diffie-Hellman solves that problem. It's one of the earliest practical examples of public key exchange, and it allows two parties that have no prior knowledge of each other to jointly establish a shared secret key over an insecure channel. You've probably used it several times today. So how does it actually work? Let's say that I want to talk to Min across some public space. In order to pass a message safely through the public space where nobody could see it, I want to encrypt a message in my private space, and then I can pass it to Min and she can decrypt it in her private space. So how do we do that? If we both have private keys, and I'm using colors here to represent the private keys, Diffie-Hellman is, there's some math behind it. If you're curious to learn more about that, there's a link on this slide that you can navigate to, but this is a good approximation of what's happening behind the scenes. Okay, so the keys that Min and I have, they're both unique, and they should never ever enter the public space. As soon as they're in the public space, other people can see them. They've lost their ability to be an effective lock. It's like giving everybody a copy of your house key. So if Min can't tell me her private key, and I can't tell her my private key, how are we going to decrypt messages that we send to each other? Enter the common value. This is a shared constant that's provided when we start talking. There's actually a couple standard common values, which just helps reduce the number of interactions that folks have to have, so back and forths, to get that common value. It is going to be the key to our keys. If Min and I both take a copy of the common key and we blend it with our private keys, then we are able to create a blended color that we can put in the public space. Someone watching in the public space may be able to realize that because Min has, the common key is yellow and the resulting color here is orange, they might be able to figure out that Min's key is red, but they don't know how much of the key was added. So she could be at any saturation level of red. They don't know. And that is also true with my green public key that's shared here. So if Min and I have both put this blended public key into the public space, that's great. I can see what the MC combination is and she can see what the HC combination is, but I still don't know what M is and she still doesn't know what H is. So there's no way for us to get value out of that. However, once we take a copy of each other's public values, we can then blend it again with our own private key. And the resulting color is now the same for both of us on either side. So if you use the same combination to blend information. So what happens now is we both have an MHC private key and are able to encrypt messages in our private space with that MHC key to pass it to the other person and to use that key to unlock the information. So Diffie-Hellman is kind of like one of those locker locks that you have, and I don't know if you've ever seen in the movie, but it is possible for people to crack those. They like listen to the lock to hear it come undone. Diffie-Hellman's key is 2 to the 4,000th power, has that many numbers on the lock. So you can hack it, but it takes an enormous amount of time. Since about 2015, Diffie-Hellman has been considered hackable by those with large compute resources. So if someone focused all their energy on decrypting your messages, they could do it. They would need enormous resources in order to be able to do so. So this is still quite difficult to hack. It is possible to hack. And I believe I should be passing this to Min.
So yeah, let's talk about saving data correctly. A lot of applications require a user to sign up and log in with an email and password. It's a very common pattern, and I'm sure some of you have built apps that do the same thing. But it's really easy to get that wrong, and the consequences, as we've said over and over again, can be bad for your user. One reason is because people use the same passwords everywhere. So if your application was compromised and their password got leaked associated with an email, now hackers everywhere can try that email password combinations on a number of different websites and gain access to those other accounts. People, might lose money, identity gets stolen, etc. Lots of bad things might happen. So a lot of care should be taken to secure your user's password, and the same is true for any sensitive information. So let's talk about how to do that. Rule number 1, don't store it in plain text. And plain text is just, like the word by word. If my password is password and you store password in your database, that's bad. Don't do that. Databases can be compromised. You can look up things called SQL injection attack. It's easy, not easy, but it's possible and for hackers to get access to your entire database. Even if that doesn't happen, employees of your company, your developers, people who have access to your database can easily have access to the password, which doesn't seem right. Just because I work on an app doesn't mean that I should have access to your email and password combo. Rule number 2 is to always hash your passwords. What is hashing? It is a function that takes in some input and spits out some nonsense output. It has a couple of important properties. The first one is that if you give it the same input, it should always give you the same output. So here, if you give it the string, my very special secure password, it should give you this nonsense kind of random looking string. Another property of hashing functions is that if you change any part of the input, it should change the output as well. So in this example, you can have, you see the inputs and the outputs of the hashing, and you can see that cat and cats are very similar. The only difference is the letter S, but the output looks super different. And you can't really work out what the input was from just looking at the output. And that's another super important property of hashing, is that you can't work backwards. Hashing is a one-way street. So just keep that in mind, is that it's very hard to know what the input was if you only have the output. So how does this help us? Let's walk through a user sign-up flow. Let's say we have a user who signs up with this email and password. What we want to do is pass the string through the hashing algorithm and get out this gibberish, this nonsense string. This nonsense string, this password hash, is what we actually store in the database alongside the email, not the original password. So now if a user is trying to log in using that email and password combination, this is how it's going to work. They go through, they pass in their password, we hash it, we get out a string. At the same time, we're going to look up their information that we store in a database by their email and get out a password hash. You can now compare these strings, and if it matches, then you know that the user had input the correct password. And if it doesn't match, then you know they input the wrong password. So for completion, here's the slide. If they pass in something else, then the hashing is going to look different, and that's the wrong password. So how is this more secure? Well, what we achieve is that we're only storing nonsensical strings for the password in our database. So people who work on your application, who have access to your database, they can't work out what the original password was from just looking at this table. That's pretty good, but we're not quite done. So the bad news is even that hash passwords can be hacked. Let's say a hacker gets a hold of this list of from your database. What they can do is work out the original password by guessing. they can like guess, they can, if they know the hashing function that like, and usually those things are available, or they can guess what the hashing function was, then they can like generate lots of hashes based on password guess, starting with some really common passwords like password or password123. And then they generate this huge list, and then they compare the list that they generated to the list that they got from your database. And because they generated this, they know what the input was. So here you can see that there is a match. And so we know that for user-example.com, their password is password. This approach is called brute forcing the password because it means they're trying all the possible combinations to figure it out. This requires a lot of computation power to generate all the passwords, and it can be really slow to crack passwords this way. But once they've found the match, then they can like share the information on the internet. And these tables that are called rainbow tables. So other hackers can like, they don't have to start from scratch. They can just look up, you know, rainbow tables and compare the table with the list of data that they got from some application. So yeah, not with many things that you'll learn in security and privacy, there's no perfect solution. There's nothing that's completely safe, unhackable. But the goal here is to try and make it really hard for people to break through your security so that it's not worth the effort. Like if it costs them like hundreds of thousands of dollars to build up the computing power to compute, you know, to crack one set of password, then it's maybe not worth it for them. And here you can like do a little extra thing to make it even harder for people to crack your passwords. And that brings us to rule number 3. You should always use assault when hashing your user password. Assault is just an additional nonsense string that is added to the user password before we hash it. So let's go back to this original diagram that you've seen before. We're going to add one step here, you know, a little salt, the red string at the end of the password. Now the hashing output is going to be different, and that's what we store in a database along with the salt string. So when a user signs in, they pass in their password without the gibberish that we added to the end of the string. We are going to, because we saved that salt, we can add it to the string, hash it, and then compare the output. And it works pretty much the same way. Like what that achieves is that, let's go back to these tables. Let's say someone got a hold of your user data and they have these rainbow tables. When they used to be able to guess, you know, password, now they can't do that anymore, because even if your user passed in their password as password, because we appended that random string to the end of their submitted password, their hash is going to look completely different. So there's no longer a match between these two tables. What the hacker has to do instead is like try to brute force again, recompute all the guesses with the salt of each user. And that's going to significantly slow them down. And it's going to be really hard for them to guess all of your users' passwords. So that brings us to rule number 4. Passwords are fine and if you do it correctly, but you can do other methods of authentication as well. Passwords have a lot of downside because if you pick a secure password, it may be very long and complicated and has random characters that are hard to remember. So what people do is that they end up picking really easy to guess passwords, some combination of their name or their family, their children's name, birth dates, etc. It's super easy to guess. So if you can offer other authentication steps for your user or some alternatives to password, that would be ideal. Here's a list of additional or alternative authentication options. Everyone here has probably used Facebook or Google to log in to other applications, right? Instead of passwords. That's probably a good idea because Google or Facebook are big companies with like a lot of people working on these things. So probably the system they built is going to be more robust than like a random application. Two-step authentication is another good one. It's when you log in using maybe email and password, but then it also like involves a second step where the app sends a verification code to your phone or your email, and then you have to type that code in. So like it's not enough to just have your email and password. You also have to have access to the device that they send the second step authentication to. So yeah, I won't go into everything, but this is a list of additional things that you can consider giving to your user in addition to or instead of passwords. The final rule I want to leave everyone with is don't try to do everything from scratch or figure it out yourself. Don't write your own hashing functions. Like hashing functions are really hard to write. There are libraries out there that people already wrote that you can reuse. And don't feel the need to reinvent, like there are tutorials for the specific framework and language of your choice when you're implementing user sign up and login flows. Security standards also changed, like the information that we presented here today may become out of date by the time you get around to actually implementing these things. So just do your research before you build. So yeah, these are the 5 rules that we've discussed today on how to store your user passwords. Don't do it in plain text. Hash it with a salt. Try to offer more than just passwords, and don't try to do it from scratch. And with that, we come to the end of the presentation. Some of the things we talked about today is that data privacy is important. It should be treated as a first-class concern. It's much easier if you just address it from day one instead of try to retroactively address it later once you already have lots of user and have already built a bunch of application code. We also learned that there are many ways to improve the security of your user data. Cryptography is one of them. As a developer, you have the responsibility and the power to secure your user data. And that's it.
So I summarized a few questions that I saw. One was that like some apps, they use like, you talked a little bit about two-step authentication. Like, is that different than regular login because it requires 2 data sets, or like, are they using different encryptions at different data sets? People wanted a little bit more information about, like, besides having to log in twice with the 2 different steps, how does that increase security?
Yeah, how it is more secure, it just means that, like, let's say you use your password is compromised, like the hack, it's on the internet. People know that like your email has used this password before. That information alone is now not enough to hack into your account, because whenever they use that password email combination and you've enabled two-step authentication, they also need your phone now in order to log in. And that's how it's more secure. It's not because of extra encryption or anything like that. It's just the fact that you need an additional device to log in.
Okay, yeah. Perfect. Kind of hard to duplicate that. So the other question I think is from a young technologist is like, how do I incorporate some of these things into my technology? I think we talked a little bit about like, don't build your own hashing algorithm or write your own code. It's complicated resources. If you have any libraries you suggest or resources they should be looking into, so they don't start from scratch.
Yeah, I think Google is like really good if you just type in like cryptography and then the language of your choice. So like crypto is one example of a library for JavaScript. If you're building applications in JavaScript, they have it's just a library with like a lot of cryptography implemented for you that you can use. But here on this slide, I think we also have like Auth0, like they also handle authentication as a service so that you can like read their documentation and blogs for like best practices and tutorials on how to do these things. I think they have a tutorial on how to like implement your like passwords in the way, using the ways that we've talked about in this presentation.
Great. The other question I'm seeing is using network drives, like cloud drives for like sensitive and important information. Do you guys feel that is a secure way to store data?
So it depends kind of on the sensitivity of the data. If you have the responsibility of controlling something like other people's financial data or somebody else's medical data, those are things that are very, very important to keep secret, and I would not recommend putting them on these like file sharing methods. But if you're talking about something like Google Drive or Dropbox, the security would be as good as the security of logging in to those accounts. Most of these file sharings are based on access. So if I share a file, I can say, I want to share it with Hannah at Transcend.io and Min at Transcend.io. And that is exactly as secure as somebody being able to log in to Hannah's account or Min's account. So if they haven't set up two-factor authentication and they reuse passwords, then it's probably not very secure. So if you're sharing with a wide group of people, especially, it's generally not a good idea unless you're in an environment where you can be very confident that everybody you're sharing with has very extensive and they're using multi-factor authentication and all the best practices we talked about here. to make sure that the only people who could see your data are provably the people you want to be sharing with, and it couldn't be somebody else impersonating them. Thank you for having us.
Thanks for attending. And
Thanks
all
for
the questions.
attending.